Hello friends, it's Mike, Bodywork teacher in Seattle, just out for a little bit of a run. And while it feels a little awkward to be holding a phone doing it, the fact that this is happening at all is a miracle of human evolution. Right now, my feet are dynamically sensing the ground and my body is elastically absorbing and returning force. And it's this ability of human bodies that I want to talk about in this week's Embodied Happy Hour live stream, 6:30 p.m. on Thursday, that's Pacific time. To do this successfully, humans and other animals need to have a marriage of connective tissue, spring mechanics, and nervous system tuning. And together, the two systems collaborate to adjust to changing conditions and efficiently absorb and return force. Just like I almost tripped there. So to figure out how this happens and how to remediate it when something goes wrong, let's go inside to the whiteboard. Okay, I'm back from the run, and now I'm wondering which elements in my system made that behavior possible. Well, human bipedal running is really one example of spring biomechanics, which is a behavior that evolved over and over again on this planet, at least for the last billion years. And whether the purpose is locomotion or vocalization or reproduction, it always involves a marriage between the nervous system and the connective tissue system. And the key parameters here are tuning and timing. You need to be able to dynamically tune the tension on the spring system, and you need to coordinate the timing of absorption and return of energy. And to do that in a human system involves a really interesting admixture of elements that we don't normally think of as a system. So let's take a look at it together. Suppose you're walking in this elegant drawing that I made. Suppose you are conveying yourself across ground in walking or running. And what you're having to do is to rhythmically meet the ground, absorb its force, transfer that force through your body, and then pivot to make another footfall, right? So let's zoom in to the lower leg here and observe that everything in green, I'm trying to draw a dense collagen or a fascial layer. And so you can see that upon a footfall here, the heel is being driven up and back. There is a sudden shock, in this case a slackening shock, to the Achilles tendon and calf muscles over here. This linear element flows over the heel bone and then becomes the plantar aponeurosis. And so as it rounds the corner, it's getting a very different kind of shock. But you can see that the stiff, elastic wrapping on that calcaneus, that heel bone, is a local spring. It's absorbing and then returning energy. And likewise, that local spring is connected into a larger lattice of springs going up the leg. And the springs come in two varieties. There are linear springs, like the one I told you, which then continues on up through the hamstrings and sacrotuberous ligament, etc. And there are annular, there are ring springs. They wrap around connective tissue compartments. And what they do is they resist expansion from fluid pressure, which is another thing that happens when you absorb shock. There's more fluid pressure traveling up each limb. So that's the connective tissue system. You have these linear springs and these wraparound springs. And you have the local connected to the systemic. But all of these springs are tuned by local musculature. So whether it's the muscles in the lower leg or the muscles in the foot or even higher up in the body, the key thing that these muscles are doing is not necessarily pushing off, which is something we train for a lot. It is tuning up the spring before the impact such that it can absorb and return optimally. And that second kind of behavior is what we train for when we do plyometrics or dynamic loading and unloading exercise. We're training the system to guess as to how much pre-stress the local springs need, the whole spring needs, to get the best response. That tuning is actuated by muscles, and it is coordinated by the nervous system. How does that happen? And how does the timing of the whole thing happen? Well, it's a feedback loop. You have at each of these junctures all the dense places, and especially the seams in muscles or tendons, the clefts and things. You have this tendency of peripheral nerves to project into those areas some specialized receptors. These are receptors that can give information really quickly about the changing forces and spatial parameters of a local system. So at this, at this zoomed-in shot of where the calf muscles become the Achilles tendon, you can see that like local myofibers, local muscle fibers, are interspersed with specialized fibers that measure length change. That's connected to a peripheral nerve. Likewise, the tendons are occasionally innervated with very fast adapting things that are wended the way in between the tendon fibers. They get squashed when the tendon is taut. Then you have other receptors that measure sort of shear stress between layers or vibration. All of these are flowing in from these peripheral nerves in a very dynamic and fast way into the central nervous system, where it is informing both the tuning and the timing of the system. And so now we're going to talk about what's happening during the run, and then we can talk later about how we adapt to running stresses over time and how that can lead to injury. So let's look at during the run. As these elastic events are transpiring, you have all this information flowing up into the central nervous system. And where it's going, at least one place it's going, is it is feeding information into what we call the central pattern generators. And these are absolutely key for understanding bipedal gait. There is one in, roughly this level of the body. If you were to find the junction of your lumbar and thoracic spine and place your hand there in your back, you will be at the level of your body where the spinal cord houses a local brain whose job it is to generate the pattern of bipedal motion. So think lumbar devoted sort of like spinal cord. It has a habit, has a sort of preset gait that theoretically could be sending its signals even with no input. But in the human, in any real human, you have this pattern generator taking in momentary input from all these sensors and adjusting its parameters, modulating its tone and its timing, etc., based on input. And then, of course, the motor output from that is thus shifted. So one level of processing where this is really important is in the spinal cord, lower spinal cord. And then the other really important one to talk about is in the midbrain. So you've got spinal cord, medulla, pons, with the cerebellum in back, and then midbrain is the last bit of the brainstem before you spread out into the whole cerebrum. And at the midbrain, there is a sort of family of neurons that we call the mesencephalic locomotor region. This is the other key central pattern generator for bipedal running. And this is for more high-level things. So the reason I was able to hold the phone on the gimbal and talk to you while also running was because of the coordinated tasks at this level, which then is able to tune the lower central pattern generator in the spinal cord. So this is what's happening during the run. Dynamic spring behavior and this coordinative role of the central nervous system mediated by mechanoreceptors that are embedded in the tissue. Now, the body does what it can. The nervous system does what it can to modify the behavior in the moment. But no behavior is perfect, and so the body encounters stress, sometimes overwhelming stress when engaged in running. or other spring behaviors. And what happens after the run is that you've got a process of remodeling happening. The nervous system might learn some new set of behaviors. You might get better at running neurologically. And at the same time, the fibroblasts that are living in the collagen matrix, a bunch of little sweet potato-shaped cells that when they get stressed out, when they get stretched by an act of running, they go from sweet potato shape to pillowcase shape, and they grab onto the matrix around them, they tune it up, and they also secrete new collagen, new ground substance. They build up the tissues that have been stressed. This is the process of training. So you are getting hypertrophy of your muscles, you're getting more collagen density mediated by those fibroblasts, and you're getting learning happening in the central nervous system. One of the key things we know about running in particular is that sometimes there's a local problem that needs to be solved. Sometimes there is such a localized stress that it really fails at one given point. And then it is worth our clinical attention to try to give that point as much relief as possible, to name it, to focus our treatment efforts on it or in relation to it. But oftentimes we jump to that kind of conclusion. I'm having trouble running, and I want to know what part of this machine is the damaged part. And that may not always be the right question to ask, right? Because sometimes it's not about a single failure point. It's about a failure in process. And so the first advice you should be giving folks who are having trouble running is a process of graded exposure. That means that you start with a really easy version of whatever behavior you're doing, less stressful on the system, and boringly simple to do for the person. You want to start in that boring range. And you have them gradually up the stress on the system, either through effort or time or whatever, and give this system enough resources and time to adapt. And when that adaptation is happening, it's happening at all these levels. It's happening through remodeling and through the learning of the central nervous system, remodeling and hypertrophy. That doesn't, of course, cover everyone. Sometimes we have puzzles to solve, but every time we are working on a puzzle whether it's in our own bodies when it comes to running, or when we're talking about someone we're trying to help, if you're a movement teacher or a body worker, the right strategy might be to try to solve the local problem, but then always zoom out, always observe the whole mechanism in action, the whole behavior in the moment, because that is where you will see whether or not this local puzzle is still fitting into the whole. And when it does, there will come a point where the behavior itself becomes the best medicine. So your job is just get them back to the place or get yourself back to the place where you can do some gradation of the whole body behavior. And then that's the place where doing the thing in a gradual way can be a very beautiful way of healing and becoming more functional. Of course, we need all kinds of help along the way. But I would advise us to keep in mind this sort of fluid spring and this linear spring sensed by mechanoreceptors and coordinated by central pattern generators in the lumbar and midbrain central nervous system, and see what this thinks. If you're interested in more information on this, you should consider joining me for two things. Free live stream this week, Thursday, 6:30 p.m. Pacific on Facebook and hopefully YouTube. And then also, a week from this coming Saturday, I'm teaching a whole online class on the foot from a nerve-fascia perspective. So we're going to be getting into that on Saturday the 16th of May. So if you like this stuff, please feel free to follow Neurofascial Approach or follow me on YouTube. And thank you for listening. Hope you have some fun running or engaging in other spring behaviors in your quarantine time. See you on Thursday.